Hello students, are you struggling with stereoisomerism? Then you are in the right place. Welcome to the Organic Chemverse, where we tackle the toughest organic chemistry question and break them down into easy understandable steps. I'm here to help you build your confidence and to tell you how simple organic chemistry can be. Let's jump into today's problem. We are supposed to identify what is the relationship between the given molecules. That means, are they homomers, enantiomers, or diastereomers? In order to do so, we need to analyze the molecules carefully. Let's write down the given molecule. The given molecule has one chlorine above the plane, one bromine below the plane, and one bromine above the plane, like this. The other molecule, right, this has chlorine above the plane here, right, and then bromine below the plane and bromine above the plane. That means what? This also has two bromine, this also has two bromine, and one chlorine here and here. In order to compare it, it's better to rotate one of the molecules so that we can see where the groups are positioned. What I meant is, let's rewrite the given molecule in such a way that the comparison becomes easy. So I'm going to rotate this molecule by 120 degree. That means what? When I rotate this, the chlorine will come on the top here. This will be the chlorine position. Now, what about the bromine? It goes here and it is below the plane, like this. And what about this bromine? It goes here and it is above the plane. This is above the plane, right? Now let's compare between this and this molecule. After rotating 120 degree, look at the chlorines. Both of them are above the plane. But here, these two bromines are kind of mirror images. And same with this also. That means the whole molecule is mirror image of the first molecule. That means they are non-superimposable mirror images. That means the relationship between these two molecules is enantiomerism. So they are enantiomers. This is one way of finding out the relationship between the molecules. What is the other way of doing it is, you can assign R and S configuration for the chiral carbons. We can start assigning R and S configuration from this carbon. Now, which gets the highest priority? Bromine, and carbon attached to bromine, and then carbon attached to chlorine, and there is a hydrogen above the plane that gets the least priority. Now, you move from 1 to 2, 2 to 3 and check where is it going. It is going in the S direction. That is anti-clockwise, that means S. But whenever hydrogen is above the plane, S becomes R. That is the final configuration. Now, this is a mirror image of it, right? So, let's check this also. Now, the carbon is attached to bromine, that gets the first priority, and this is second and this is third. And how is it moving? It's moving 1, 2, 3 like this clockwise, and hydrogen is below the plane. That means what? R. So both the carbons here are R and R configuration. If it is an enantiomer, these two must have S and S. Let's verify that. This bromine first priority, and this is second and this is third. So how is it moving? It's moving in the anti-clockwise. And where is the hydrogen? It is below the plane, so S will remain S, right? Now let's check for this carbon. First priority, and this is second and this is third. How is it moving? And here it's going clockwise. but hydrogen is above the plane, so it will become S. The configuration here is S and S. And here it is R and R. What is the relation between R and SS? They are enantiomers. This is a confirmation that the given molecules are enantiomers. And students, if you have observed here, I did not do R and S configuration for this particular carbon. Why so? Because that particular carbon is a chiral. You see, there is a chlorine, but these two carbons are attached to the same atom, that is bromine. Therefore, we are not doing R and S configuration for this particular carbon. So this is how you can tell whether the given molecules are homomers. That means they are same, exactly same. Say suppose it's RR, right? So then they are homomers. Enantiomers, they are non-superimposable mirror images. What about diastereomers? They are non-superimposable non-mirror images. So we call them as diastereomers. I hope it is crystal clear to you. And if you still have any doubts or questions regarding isomerism, you can always ask the questions in the comment section. Thank you for watching this video. Until next time.